will hold a presentation about monitoring with Pacemaker.
Great, wonderful. So, good morning, everybody. Thanks for being here today at this presentation on the subject of Pacemaker and monitoring. Before I start straight into this subject, please give me the opportunity to introduce myself. That is me, and this is where I'm living. I'm living in Vienna, in Austria. For those of you who have ever heard me speak German, they will know that I'm not originally coming from Austria, but I was born in Germany in a very small village very near to the Dutch border. You might have read some articles that I wrote, as I am a fairly regular publisher. I'm writing for these magazines, and if you've not seen me there, then you might just have been using some packages that I have created. I'm a Debian developer. I mainly maintain the Linux HA cluster stack for Debian, which is Heartbeat and Pacemaker and CurlSync and all these things. And I'm also a very frequent visitor of conferences and exhibitions, so you might just as well have met me at some exhibition before. My favorite hobby is this one, so if you ever are in Vienna, then please just drop me a note and we'll go through some strikes. And if between all these things that I do, I still find some free time, I even do work from time to time, and that is the company that I work for. It's a very young company. I used to say we're a startup, but I was recently told that if a company has survived its first year, and it's not a startup any longer, so I can just say we're a very young company. We are active mainly on 3 fields of business, one of them being OpenStack consultancy and training, the second being storage with object storage and storage solutions for high availability clusters, and the third being the subject of Linux HA, Pacemaker, and everything that is related to high availability on Linux. So, before we start, I would like to ask you some questions. Who of you has ever used Pacemaker before? And who of these people is still using Pacemaker? Okay, it's less people. And who of you has already used the monitoring feature that Pacemaker provides? Okay. So, I would like to start with a general disclaimer, and I'm not saying that you guys don't know how to do your job, but when I was talking to people about monitoring and Pacemaker in the last months and years, I had the impression that people believe they can use Pacemaker to replace Nagios and Isinga and whatever is going on there as a monitoring platform, and indeed that is true. Not. What I'm not saying is that Pacemaker is supposed to replace Nagios or Isinga, and please don't take this with you if you leave this room today. Pacemaker in no way is a replacement for monitoring with Nagios or Isinga for any form of conventional monitoring. So just don't uninstall Isinga or Nagios if you install Pacemaker. That's just going to work. You might wonder now, why are we here today if I can't use Pacemaker to replace Nagios or Isinga? And the point is, the only thing that's better than monitoring, of course, is more monitoring. That's the same thing you have with hardware and network capabilities and whatsoever. If you have monitoring and there are good ways to extend your existing monitoring, then just doing that is a good idea. So Pacemaker does not replace monitoring with Isinga or Nagios or any conventional monitoring, but it allows us to add another layer to it. In fact, Pacemaker allows us to do monitoring in a way that standard monitoring systems just can't provide. How so? To understand how that works, let's take a look first at how conventional monitoring systems do their job. Usually, we will have a central monitoring instance, a system that in one way or another is pretty centralized. We have one central monitoring instance, and either that instance queries the servers that it is supposed to monitor in regular distances and asks for certain values confirming or affecting the system configuration, or we have clients that automatically report these values to the central monitoring instance. I guess there's nobody in here who has not used such a setup in production, is there? Okay, so you guys know what I'm talking about anyway, that's great. Imagine you are running such a monitoring system, if you don't run it anyway, And now imagine there's a typical 2-node cluster in such an environment, like this one. Often you will have DRBD present in such installations, and very often running on top of your storage solution there will be a MySQL database, for example. So let's assume this 2-node cluster is running MySQL. And now let's assume that MySQL just crashes, which it tends to do from time to time. Imagine MySQL is going down for whatever reason. Isinga will certainly notice after some certain amount of time. Typically, you will not pester your database with a monitoring query every 10 seconds, especially not in those cases where you have a high-load database already anyway. So let's assume Isinga finds out that MySQL is broken after just 2 minutes. It will alarm somebody either by email or by SMS or by whatever, and somebody will hopefully read that notification after some time and then go and fix MySQL. Even if you assume that all this happens very quickly, the time until the problem is fixed will usually be 5 minutes or more. 5 minutes is very optimistic, especially if you assume that MySQL crashes right in the middle of the night and your operator on duty just has to get out of his bed to fix it. So this means 5 minutes of downtime, 5 minutes during which your MySQL database is just not available. Let's play the game with the 9s now. An availability of 99.997% equals to roughly about 15 minutes of downtime a year. So 5 minutes during which a service is not available because MySQL crashes means you already have a third of that time you're allowed to be down-reached. And if this happens 3 times a year for whatever reason, then you will not be able to reach an availability of 99.997%. So make sure to hire quick engineers and ask MySQL to crash not too often. And this doesn't only apply to MySQL, it also applies to other software that you can use within your cluster. Just imagine you're running Apache or JBoss or Tomcat or whatever. Imagine your JBoss is killed by the kernel for an out-of-memory problem when you try to allocate more memory than it was available at that point of time. Or imagine that due to some hardware errors, your cluster has just started to slowly shred your data because something is going wrong on the machine and your database or your file system, for example, is just being cut into pieces right now. The problem in all those cases is a fix is not available immediately. Somebody will have to take a look at the thing and fix it, and that usually comes along with a delay. And delays, in fact, are bad because during that time, our service is not available. So can we do something to automatize the fixing of problems that we have in these scenarios? And can we do something that's just going to fix our MySQL if it crashes, or to fix Tomcat or JBoss or whatever if these things go down? And the answer to that is yes, we can. How can we do it? We could use Nagios or Isinga hooks for that. So we could make our monitoring system trigger an event automatically based by some action in the cluster, by process crashing, for example. This, however, appears to be highly uncommon. I have not seen many setups where people really instruct Nagios to restart MySQL if it's going down on a host. Plus, it doesn't deal with scenarios like node outages. If a node crashes, then there's nothing Isinga can really do about that. And this brings us straight to Pacemaker, brings us straight to the question, how can we use Pacemaker to work around and to fix problems like the one that I have just described better? Clusters like the one I have mentioned before will usually be running Pacemaker anywhere. If you run MySQL on top of a DRBD cluster, then usually DRBD and MySQL will be managed by Pacemaker on that cluster in one way or another. So in fact, Pacemaker is right there. It's running on every node, and it's very close to the heart of these systems. It's bending over backward anyway to find out what the status of our nodes is because, well, that's just the job it has as a cluster manager. It's responsible for keeping the services up and running, and it's just doing that by finding out what state your resources and your nodes are in anyway. And so Pacemaker for us really can be something that helps us work around crashes of MySQL, for example. Long story short, Pacemaker provides us with real end-to-end monitoring, and that is something that Isinga or Nagios just can't do. Pacemaker can actually restart failed resources if we have a service that should be running but is not, we can instruct Pacemaker to automatically restart that service on the node. It can move failed resources away from the node they are running on. Imagine you have a service that keeps failing on one cluster node. If that's the case, then there's not much sense in restarting it again and again. And we can instruct Pacemaker to move that resource away to another cluster host, in the hope that it might work better on that node than it did on the previous. What we also can do is we can stop failed resources. If we realize that a resource keeps failing on any node that it's running, we can just tell Pacemaker, okay, so stop it. In that case, the idea obviously is not to provide availability anymore, but to avoid further damage caused by applications going nuts. And last but not least, we can also use Pacemaker to kill nodes out of our cluster that are acting up, that might just be shredding your data, that might just cause concurrent writes to assign storage, for example. All these are things that we can do with Pacemaker. So, sounds good, doesn't it? How can we achieve that goal? What do we have to do to make use of these nice features in Pacemaker? Well, first of all, and that may seem obvious to you, we'll have to use Pacemaker. While it's obvious right now, a lot of people just don't use Pacemaker, and there's a reason for that. If you imagine the timeline of Linux HA development, you will usually start in 1999. That was when Heartbeat 1 was released to the public. Heartbeat 1 wasn't a cluster manager, it just was a piece of software that could check nodes for their availability and start services on the one node or the other if one of these nodes went down. Then in around about 2005, we had Heartbeat 2, and the actual incarnation of the main cluster manager for Linux was released in 2009, or actually at the very end of 2008, and that is Pacemaker. The first usable versions of Pacemaker were available early in 2009. The problem now is a lot of people have just stopped here. They have stopped at Heartbeat 1 because for them, Heartbeat 2, this step of the process really wasn't ever much more than just this. And if you ever have worked with Heartbeat 2, then I'm pretty sure you know what I'm talking about. Who has been dealing with Heartbeat 2? Okay, and you're still here. That's great. That's wonderful. So the thing is, just go with Pacemaker. Pacemaker has a decent user interface compared to Heartbeat. It does work reliably. It can reliably manage our resources. So if you want to use cluster management on Linux, there's no reason whatsoever to stick with Heartbeat 1. Just go for Pacemaker. And the nice thing about Pacemaker is it brings us all the nice monitoring features that I will just explain in the next minutes. So monitoring in Pacemaker, let's talk about it. What types of monitoring does Pacemaker come with? What can it do for us when it comes to resource monitoring? First of all, Pacemaker can do node monitoring. This is the easiest and most obvious monitoring mechanism in Pacemaker. And if you want to put it like that, node monitoring is the very base function of Pacemaker as such, because the main job of the cluster manager, as I already explained, is to make sure that our nodes are hosting certain services. And if a node goes down, then Pacemaker will have to initiate a failover. So monitoring the state of nodes is what Pacemaker does out of the box and what its main intention actually is. If a node fails, Pacemaker will automatically make sure that the now unavailable services are started elsewhere. This doesn't need any extra configuration. That's just the way Pacemaker is supposed to work. So that is some sort of monitoring that we actually get out of the box and with no administration work whatsoever. Of course, if you have been dealing with clusters, then you know this process is called failover. So failover is the very basic function of Pacemaker. Also, let's take a closer look at node health flags. Pacemaker can not only act based on nodes going down. What you can do with Pacemaker is you can work around nodes that you suspect might be going down soon. And that feature is called node health flags. Let's see how they work. We do have a two-node cluster here, Alice and Bob, and we do have a property configuration entry in our Pacemaker configuration. And the line that you see in bold is the important line if you want to use node health flags. This parameter node health strategy actually takes a lot of parameters, can take a lot of parameters. The most important ones are migrate on red, as you can see here, and only green. And what this setup is going to do is make Pacemaker move away resources from a node if it realizes that there's a node flag for a node available that is, for example, red. If you want to set such a node flag, we can do it either manually. This is how it would work on the command line. This is called the hash health temp attribute for Alice, and we're setting it to red. So with this setup in place, what would happen is that Pacemaker is going to move all resources running on Alice automatically away. Now, obviously, it's not very helpful if we have to set that node health attribute manually on the command line, because that's not automatized. And after all, automatization is what we are going for. Now, imagine you were combining this, for example, with a resource that's running from within your Pacemaker installation and that checks for the smart status of your hard disks, or for the actual controller status of your RAID controller or your SAS controller or whatever. If our resource agent notices that the smart messages our disks is sending look dangerous because disks might just go down soon, we can use that information to make that resource agent automatically set the node health flag to red, and by that cause the moving of all resources that are running on that host. We could also use this, for example, when doing temperature checking. On any system, you can these days read out values of your temperature sensors at ease. And if we were having a resource that just read out these values, these temperature values, and notices there is a node which has a very high temperature, we could just move away resources based on that information from that node with the help of those node health flags. There are countless other things that you could do with that feature. Think of fan checking. If you realize that a fan in your server has just failed, you can use node health flags to make Pacemaker move all resources away from that cluster node automatically. As said, the numbers of things you can use this for are countless, and there are some good examples out in the internet on what you can do, what you can set in resource agents to make use of these features accordingly. Yet the node health feature is a thing that really a lot of people just don't know because they've never even looked it up and they have never even tried to find it. The second feature in Pacemaker that we can use to do a sort of node monitoring is node bias, or as this feature is called officially, the migration threshold. In fact, the migration threshold doesn't do anything else than telling Pacemaker if a resource has failed a number of times on a certain node, move it elsewhere. Think of MySQL again. If you have MySQL running on a host and it keeps crashing there, and you restart it and it keeps crashing again, then there are certain reasons to believe that that machine might have a hardware problem, like broken RAM or broken CPU or overheating or whatever. And what we can do in Pacemaker is we can tell Pacemaker, if you restart MySQL 3 times on a host and it crashes again, just move it to another host in the hope that it's going to work better there. So MySQL is the example we'll be using in this case. And this is a configuration of a cluster manager with a standard MySQL configuration. And please note the meta parameter that we have inserted there, which is migration threshold equals 3. What this means is if Pacemaker crashes 3 times in a row on a certain host, it will automatically be restarted by Pacemaker on another server and another cluster server that is available and eligible to run that resource. If you get to take a look at the machine and find out what's wrong with it and fix it, you can just undo that by cleaning up the resource via the CRM resource cleanup command. That command doesn't do anything else than resetting the fail count for that certain resource on the host Alice. And after doing that, you could just remove that resource to Alice back again, and the game starts all over until the next host has some problems with running MySQL. What we also need to talk about when we're talking about monitoring in Pacemaker is stonif, or as it's called in other cluster managers, fencing. Stonif is the Pacemaker word for fencing. It's the abbreviation for shoot the other node in the head. And that is exactly what Stonif is supposed to do. If Pacemaker realizes that there is a node that is acting up and that looks suspicious, and if there's a node that Pacemaker just doesn't know of what it's doing right now, then if you have Stonif enabled, Pacemaker can just shut down that machine and restart it and reboot it, and by that, avoid that box causing harm. If you want to put it like that, Stonif is an escalation level of monitoring. If normal resource monitoring doesn't work anymore, because you can't control your nodes anymore and don't have a chance to influence the state of a resource on certain hosts, the easiest way to make sure that no harm is done is by just rebooting that machine and resetting cluster services on that node. Imagine our two-node cluster again running DRBD, and now imagine that these two cluster nodes just lose their communication paths. So they both stay alive, and they both keep running Pacemaker, but they can't see each other anymore. In normal cluster operation, what would happen in such a scenario is they would simply think that the other cluster node is gone, and then both, for example, turn a DRBD resource into primary role, which is what we call a split brain, which is a bad thing. So Stonif helps us to avoid split brain situations by making sure that at this point, one of these two cluster nodes is just going to be rebooted, and by that, being kept from causing further problems in the cluster. This is not about availability anymore. So when using Stonif, we are not doing that in order to keep our services available. We are doing that in order to keep harm away from our data. Because if we do have a split brain in DRBD, then we will lose one of these two sets of data unless we are going to merge them manually, which is something quite cost intensive. But with Stonif in place, we can just avoid that situation straight from the beginning. To me, it seems like a lot of people are afraid of Stonif and killing a node with Stonif. Who of you is afraid of Stonif? Okay, so you're tough guys, that's great. If we have this situation here, let's take a look what actually does trigger Stonif events, because there are a lot of wrong opinions about that out in the air. One of the events that's certainly going to trigger a Stonif action by a Pacemaker node is if another node just suddenly disappears. Now, in the event that I just described previously, with two nodes losing their communication paths to each other, one of these two nodes will be killed by the other because these nodes to each other has just suddenly disappeared with no information what they actually have done. And this is what Stonif, in our case, is supposed to do. If a node disappears, it will make sure that one of these two nodes get rebooted, and that's what it does. A resource that can't be stopped is another reason for why Pacemaker is going to do Stonif on a host. Imagine there was a DRBD resource running, and Pacemaker just wanted to make sure that that resource was not causing any harm on the other node. It tried to stop the resource, and stopping the resource just didn't work. So the only thing that Pacemaker can do to reliably assume that the DRBD resource was stopped on the other node is rebooting the node. And that is what's going to cause a Stonif event as well. Many people do think that Stonif needs a lot of resources, hardware-wise and software-wise. That's just not true. Any standard remote administration interface can be used, and that includes IPMI, which is even available on Super Microserver these days. So whenever you do these, if you have IBM, you will probably have some RSA card in that, and that can be used for Stonif. If you're using Dell, then you have DRAG, and that can be used for Stonif. And if you have HP, then there's ILO, and you can use that for Stonif. So as long as there's any standard remote administration interface available, you can just do that. So when set up correctly, Stonif will bring no harm to your cluster. That's important to note. One thing that a lot of people just don't know is that if you have a Stonif setup in your cluster, it's a good idea to disable automatic cluster manage software at the boot time because that's going to avoid a cluster shootout. What many people fear is when using Stonif is that at some certain point the nodes will start to randomly shoot each other, and if you just disable automatic crossing and Pacemaker startup at boot time, then that's a perfect way to avoid that. You will have to do manual intervention afterwards, but that's okay compared to having a stunif shootout or compared to having data loss caused by DRBD split brain, for example. If you don't trust hardware stunif, you can just use the external meatware stunif client for Pacemaker. That's not a hardware interface for stunif, but it's a software interface. And the only thing that the meatware client does is it will halt your cluster operation and ask for manual intervention by some operator, by some person authorized to do so. So if you use meatware, your cluster will just cease operation until somebody gets to fix it. And the cool thing about that is you can instruct the meatware agent to create a status file that you can just nicely monitor with Nagios or Isinga. If the status file is there, then just have Nagios or Isinga alert the operator on duty, and by that take a look at what's wrong with the cluster that's in place. That means no data loss at all if your cluster goes nuts for whatever reason. It means a certain downtime, of course, but that's okay compared to data loss. So we've been talking about node monitoring a lot. Now let's take a closer look at resource monitoring in Pacemaker. Just as well as doing node monitoring, Pacemaker can survey our actual resources and can check their state. Compared to, or contrary to public belief, it's not difficult to set up. Resource monitoring in Pacemaker really is easy to implement, at least when it comes to the administrator side of things. If the resource agent supports it, then enabling that feature in Pacemaker is easy. A very basic example is an IP address managed by Pacemaker. Typically, that will look something like that in your cluster CRM configuration. Now, if you have that, you see the params keyword down there, and the only thing you need to do to make Pacemaker monitor that resource in regular intervals is that. Just add an operation which is introduced by the keyword, which is introduced. That's a nice bug. That's a Heisen bug on the microphone. I love that. Okay? Okay. The only thing we'll have to do in that case is adding this line introduced by the up keyword. And then you just define the interval and the timeout that you want Pacemaker to apply to that operation. In this case, Pacemaker would automatically check the state of that resource every 20 seconds. And can we just fix this? Anything that works is nice. Okay. Wow, that's cool. Right. You need high available microphones, by the way. So what this is going to do is it's going to make Pacemaker is going to test this resource every 20 seconds if the resource, it's going to test if the resource is still running. If it doesn't get a reply from the monitoring option within 10 seconds, it's going to fail a resource failure here. And that is just a very basic setup for an IP address. If things go wrong, Pacemaker will simply restart that resource on that node. So if some bad guy like me just removed that IP address via the IP address command from the host, after 20 seconds, Pacemaker will notice that and will re-add that IP address, which is sort of exactly the feature that we wanted to do in that case. So that's not difficult, is it? I mean, the cool thing is this works the same way for all resources. Actually, let's take a look at a very common use case for virtualization, and that is libvirt, that is virtualization. Who of you is running virtual domains with Pacemaker? Okay, that's baffling me, but okay. If you want to do monitoring for this virtual domain, for this virtual machine, then all you have to do there simply is this. It's exactly the same command. In this case, we're just using a larger interval because we don't want to test our virtual domain every 10 seconds, but every 60 seconds. And we're also adding a timeout that's a little bit larger because we don't want the thing to fail if the virtual machine is under load, if the host system is under load, and the reply to that command just takes a little bit longer. So it's really the same thing all the time for our resources. Whatever resource you have in Pacemaker, as long as it is a primitive resource, you can simply enable monitoring for that resource by adding that line to the configuration. DRBD is a little bit of a special case when it comes to that. Pacemaker allows us to do monitoring of DRBD resources, but compared to standard resources, DRBD in Pacemaker is a bit different. Because if you think of it, a DRBD resource on one host can have at least 2 different states, or actually 4 different states. It can be up or down, and it can be primary or secondary. And Pacemaker allows us to properly monitor for both of these values. If you set up Pacemaker in DRBD, you will have to set up a master-slave rule anyway. And you can just add an according monitoring instruction to the DRBD resource for that, which in this case will check every 30 seconds if the DRBD is in secondary mode, and every 25 seconds if the DRBD is in primary mode on that host. And that's really all it takes to make Pacemaker monitor your DRBD resources. It's just 2 lines. It's 1 line more than for primitive standard resources, but even that is not too complicated, I think. So when talking about DRBD resource level fencing, or when talking about DRBD fencing with Pacemaker, there's one nice thing to add when it comes to DRBD. DRBD has a mechanism built in to avoid time warps caused by a disconnected DRBD replication link. If you use DRBD, you will have a replication link between the 2 servers that DRBD uses to replicate its data. Now, if that link breaks down for whatever reason, you will have a disconnected DRBD, and the primary node will continue operation. The secondary node will not receive any updates anymore, but if at the time of the connection breakdown, the status of the secondary DRBD was up to date, DRBD will just allow it to become primary at any time. So if the actual primary node fails, and we're doing a switch over to the node that is the secondary node, it will become primary, but it might have a set of data that is old, days or months or whatever. And to avoid this time warp, DRBD, or actually the Pacemaker DRBD resource agent, has a function built in to avoid that, and that's using Pacemaker monitoring as well. If DRBD notices that the communication and replication link has just gone down, it will automatically instruct Pacemaker to not update DRBD on the secondary node into primary role. So we are avoiding that time warp right there. But we only do that if we get the monitoring function in Pacemaker. So let's take a look at the code side of things. We've been talking about user space implementation up to this point. What do things look like if you're a developer, if you're writing an application and you want to develop an OCF resource agent for exactly that application? And to understand how that works, we'll have to take a closer look at how Pacemaker controls resources. This is a simplified image of how Pacemaker works. We have a storage standard that's not interesting right now. We have cluster messaging, usually that's taken care of by crossing. There's cluster resource management. This is where Pacemaker kicks in. And then there's our application running on top somewhere. And now we need to find a way to make Pacemaker control our application. So simplified is this picture because it doesn't show the whole picture. What really interesting is this part. Let's zoom in there. That is what monitoring looks like. We have Pacemaker down there. Pacemaker is our cluster write resource manager. And Pacemaker needs a way, for example, to start MySQL on a host if it's supposed to start it there. Now, either we could have Pacemaker call MySQL directly, which would imply that Pacemaker needs to know how to start almost any application out there, which is highly inflexible. Or we do make Pacemaker call an external script that's just going to take care of starting MySQL for us. Pacemaker will hand over the command to start MySQL to the so-called local resource management daemon, and that will call the so-called MySQL resource agent. So from an API, from a programmer's point of view, the point where all the magic happens for starting resources really is the resource agent. Has anyone of you ever written a resource agent or taken a look at it? Who has seen one before? Okay. So, as said, the magic really happens in the API that is offered by the resource agent. And by that generic API that Pacemaker offers, we can just write resource agents for almost any application out there. And if you want to do proper monitoring of our resource, then it's obvious that the point where we'll have to implement it is this one. We will have to make sure that our resource agent does proper monitoring of a resource if we want Pacemaker to monitor it reliably. Pacemaker uses resource agents. If we want monitoring to be cool in Pacemaker, then we have to improve the resource agent. Good resource agents follow the OCF standard. OCF is the abbreviation for Open Cluster Framework, and it's a standard designed specifically to allow for standard compliant resource agents in Pacemaker. There is a guide on writing good OCF resource agents available, so if you Google for that, you will just find the whole document. It was written by Florian Haas, who has written a lot of resource agents himself. And I have just brought 2 examples today to demonstrate how writing good resource agents can work and how using cool monitoring functions in resource agents can be done. So 2 examples for that. The first one is the resource agent for the OpenPBX Asterisk. I have written that resource agent myself around about a year ago. And obviously, the resource agent is doing all the stuff you do when trying to find out if an application is running or not. Like, you check for a process ID file. If there is one, you read it, and you see if the process that's ID is noted in there is still available. It does all do that, but as you certainly know, just because a process is there in the process table doesn't mean the application is running properly. It might be there as a zombie. It might be there, but it might be broken internally. It might just be unable to provide proper service the way we expect it. So what I initially did in Asterisk to avoid such a problem was, I thought if Asterisk is running and we can use the Asterisk console to do this core show channels count command, then we can check if Asterisk is still reacting to our queries. And if that's the case, we can assume that Asterisk is properly running. What I'm doing there is I'm simply running the Asterisk command line client. I'm checking for the return value of that piece of code. And if it's not 0, then I'm printing out an error. And the monitoring operation will return a failure, which will make Pacemaker restart Asterisk in that case. Worked fine for around about 4 months when we started to realize that actually Asterisk might be running, and you might be able to do the core show channels count command, and yet the zip module in Asterisk might just have crashed, which means Asterisk is unable to do zip calls, which is sort of pointless if you have a zip Asterisk. So the solution to that was we need to ensure that we can do proper zip calls with Asterisk. You're seeing another snippet of the same resource. We're using the zipsec client in that case. What's important here is that part, because this part of monitoring is configurable. We're leaving the choice to use this feature to the user. If the user defines a parameter that is called monitor zip URI, then Pacemaker will do this sort of checking. It will call zipsec, and it will make zipsec call the URI specified. And if that command is successful, it will return 0. If it's not, then it will return errors based on the return code that zipsec has just delivered us. Up to this point, this has been working pretty nicely to monitor zip. And if Pacemaker just doesn't do zip calls anymore, then it will if Asterisk doesn't do zip calls reliably anymore, it will just restart. It will just be restarted by Pacemaker if users decide to set that option. If they don't, well, then that part of the code is obviously left out. The second example, again, is virtualization with libvirt, which is in use by many people. This looks a bit crowded, but actually it's quite easy. Again, we have a parameter up there that can be defined by users. If users define the monitor scripts parameter, then this part of code will become active. And the cool thing is the monitor script can just be anything that's scriptable on bash, as long as you're able, or any other shell of course, as long as you are able to influence the return values that come out of this thing. So as we all know, just because there is a QEMU KVM process on a host, that doesn't mean that the virtual machine this QEMU is running is really working as expected. It could just have had an internal kernel crash, a kernel panic, and might be unable to provide service. And what we're doing here is we're calling an external script, and this script could virtually do anything. It could just do a ping on the virtual machine's IP address and return an error value if the ping isn't answered as expected. It could also log into the virtual machine and ask for some status of some file or execute a command and find out if that works as expected. The number of possibilities here are countless, and we can just define multiple monitor scripts to even make further use of that function. So if you're using libvirt and VirtualDomain and Pacemaker, then taking a look at this might be worth some effort for you. From the user perspective, all they have to do to make Pacemaker use that external monitor function really is they just have to add another configuration parameter, which is called monitor scripts, and there you can just add a list of any script you like, comma separated. That's about that. You can even add 20 scripts there if you want to. There are no limits for that whatsoever. So there's one last thing I would like to point out. I don't know how you feel about being fooled, but personally I'm pretty unhappy when I realize that I am being fooled by somebody, at least if it's not being fooled in a funny way. And the same thing goes for Pacemaker. If you tell Pacemaker to monitor your services, then it will just do that. And if you realize that you need to do maintenance, then tell Pacemaker to keep its hands off your resources and your cluster nodes, because otherwise you're gonna enter a world full of pain. Like GitHub did recently. They published a blog post in which they blamed their current outage on Pacemaker. And if you read that blog post, you will see what they did. They were doing a database migration, and they had Pacemaker active, and Pacemaker was monitoring their resources actively. So during that migration, they had a lot of load on their database, and when Pacemaker tried to monitor their database, that just got in timeout because the database wasn't able to answer quickly enough, which made Pacemaker believe that the database is broken because that is what it was configured to believe, and which made Pacemaker then restart the database, which didn't make the GitHub people too happy with regards to the database migration, which led to some fun for the GitHub people and some extended downtime for GitHub. You know, Pacemaker doesn't have the easiest and most intuitive user experience ever, and I'm certainly not going to defeat it for that over here. So if things go wrong, it appears there is a general convention to blame stuff on Pacemaker if it was involved in one way or another. In this case, it just wasn't. It just did what it was supposed to do. And that's a shame because really trouble avoiding is so easy with Pacemaker if you know how to do it. If you tell Pacemaker to monitor your nodes, and if you tell Pacemaker to monitor your resources, there are two easy things you can do to avoid trouble. One is, if you need to do maintenance work on a specific node, then just enable standby mode for that resource, for that node. That's going to make Pacemaker move all resources away from that node, and after that you can just do on that node whatever you want. You can reboot it, you can destroy it, you can blow it up, whatever you feel like is going to be fine with Pacemaker. It will not intervene. If you have to do cluster-wide maintenance, like a database migration, then just enable maintenance mode. That will make Pacemaker leave your resources alone completely. No matter what type of monitoring you have set up and configured, with maintenance mode enabled, Pacemaker will just not interact in whatever you do, and will just leave you do your work until you are done. And when you're done, just don't forget to disable maintenance mode, and that will absolutely re-enable Pacemaker and make it monitor resources the way it was monitoring them before and the way it's supposed to monitoring them actually. So, long story short, Pacemaker can actually provide us with a form of monitoring that conventional monitoring systems like Isinga or Nagios just can't offer, especially when it comes to real end-to-end monitoring and ensuring the integrity of your data. And with that, I am giving you 2 URLs. If you want to find out what we're doing with regards to Pacemaker and Pacemaker monitoring, then take note of the URL down there, where you will find all stuff that we publish about Pacemaker. If you want to ask something to me personally, then you'll find my email address down there. And with that, I'd like to ask if there are any questions right now. So if there are no questions, then thanks a lot for your attention, and I wish you a nice conference.